Okay, now let's move on to extended ACL. Okay, extended ACL is used for more precise traffic filtering control. So for extended ACL, we use a number 100 to 199 or 2000 to 2699. This gives you a total of 800 possible extended ACL. Filtering criteria includes source packet address. So this is standard ACL, can do by source packet address. In addition, extended ACL can filter based on destination address, protocol, and even port number. Okay, meaning for packets that is traveling in the router, this packet, the router can look at the source IP, can look at the destination IP, can look at the source port, can look at the destination port. You can also look on the whole. This packet, what protocol is this packet? Okay, is it a ICMP packet, IP packet, TCP packet, UDP packet, and so on. Okay. So extended ACL give you more controls. Okay, give you a greater range of controls. Okay, this shows the logical path used by the extended ACL. So let's go back. Let's go through them. So when there's a packet that comes in to an interface, the router will check is there an ACL defined on this interface that is coming in. If yes, okay, then they will check source IP address, does it match? If yes, they will check does the protocol and the port match. If yes, they will check whether the destination IP address match, okay, with that ACL, okay, of this packet that's come in, the source IP address match, protocol match, port match, source port match, destination IP match, destination port match. If yes, then they will either allow or drop the packet based on the permit or deny condition. Okay, if permit, it will be allowed to go through the routing table. If it deny, you drop the packet. Okay, if any of these conditions doesn't match, any one of them, okay, it will then move on to the next ACL. Okay, so unless it's the last ACL, otherwise they will move on to the next access control list statement, and then they will try to match again. Okay, all the entries must match before they then decide that this is a entry that match, and then they will drop or permit the packet. Okay, so if you drop, the packet will be dropped. If it's the last statement and we still can't find a match against the implicit deny any statement, okay, at the last statement, you also drop the packet. Okay, then if it's permitted, then you'll go through the routing table, and then you'll send out to the outgoing interface. Okay, so for extended ACL, you can check for more things, give you more precise control. Okay, the ability to test on protocol and port number give you very specific control for your ACL. Okay, so for the port numbers, there's two ways to specify it, either by writing out the number or by the well-known port. Okay, this is an example. This is an extended ACL. Okay, you notice this equal, so equal to a port number, or you can also say equals to a well-known port. Okay, so this operator equal. Okay, normally we'll use equal, but if you can also use not equal and EQ, greater than. You can replace this with greater than or less than certain number or greater than certain number. But most of the time we use equal. Okay, next. Okay, you notice you can use either 23 or use the keyword telnet. How do we identify this keyword? Okay, how do we know that this telnet can replace 23? Okay, to find out the keyword, we can use the question mark. Okay, let's go to a router to take a look. Okay, for example, I'm in this router. Okay, let's create a extended access control list. So let's say I got to use a number more than 100 or greater. So I use 100. Okay, access list 100. Let's say permit. Say TCP protocol from a host 10.1.1.1 to another host 10.1.2.1 equals to here. You can either, let's say telnet, you want to permit telnet, you can either use port 23 or you can use the question mark to find out what is the keyword. When I enter here question mark, you notice the keyword appear here. Okay, and this is a description of the port. So FTP, file transfer protocol, POP is post office protocol, and so on. Telnet is over here, and the number in bracket is the port number. So here I said I can either use 23 or I can use telnet. Okay, so this is the way to find out the keyword by using the question mark. Oops, sorry, by using the question mark. Okay, so these are the keyword. Obviously, okay, one thing to note is, look at here, port 80. Port 80 is known to be HTTP, okay, but for Cisco, they define the keyword as www. Quite strange, but that is how Cisco define port 80. So a common mistake that I see is students tend to put www, okay, which is wrong. They should put, students tend to put HTTP. Okay, this is wrong. If you do that, Cisco will say error message, error is detected. They don't recognize HTTP. So in this case, you want to use port 80, you must use www. Okay, so the keyword is very specific. Okay, obviously here only have 5 keywords with 5 ports number, and in Cisco router, there's obviously more than these 5 well-known ports. So what are the well-known ports that's recognized by Cisco? Okay, these are the well-known ports. So here is an example where here is question mark, and these are the port numbers. Okay, in Packet Tracer we only support 5 keywords. In the real router, there's actually a lot of keywords. Okay, there's a big list of keywords you can use. In any case, if you're not really sure about the keywords, you can always use the port number recommended. Otherwise, you can use the keyword. Okay, let's say I use port number. Okay, let's say I remove this access list. Okay, when I do a show access list, okay, there's no access list. Okay, I put this access list back again, and here I put port 80. Okay, when I do a show access list, you notice Cisco automatically change this. Okay, from 80 to www. They auto change it, the keyword for you, so you don't have to worry about not remembering the keywords. If you remember the port number, that's good enough. Okay, I have given you one or two examples of configuring extended access control list. This is a full syntax. Okay, rather than going through this full syntax, let's go through a few examples to let you it's easier to understand. Okay, this is one example. To restrict internet access to allow only web browsing. Okay, so here there is this one local area network 192.168.10/24. Okay, and I want to restrict internet access. The internet is here. I want to restrict internet access for this group of clients. Okay, to go out to the internet to only web browsing only. So for web browsing, okay, the two protocols are HTTP and HTTPS. And this is port 80, this is port 443. Okay, so here I created access list. Okay, access list 103, 103. Okay, these two access lists, okay, belongs to the same group. Okay, so access list 103, I'm going to permit. Okay, web browsing is a TCP protocol. So permit TCP. Okay, from source is here. Okay, 192.168.10.0, 192.168.10.0. This is the source. Okay, and this is a /24. So the wildcard is 0.0.0.255, 0.0.0.255. Okay, to the internet. Okay, the internet consists of many IP addresses. So many websites, many IP addresses. So it's not possible to specify all the IP address here. So in this case, I say any. Okay, then so the destination port. So if I want to allow only web surfing, is this a web server? The port number open here is port 80 or port 443. Okay, So here I'm saying that I'm going to allow packets going out to the internet if the destination port is port 80 or port 443. Okay, so I'm allowing these two type of packet to go through. Okay, so what happened is when this router R1 receive a packet from this network, he will check, okay, the source IP. Does it belongs to this group? Okay, he will check the protocol. Is this a TCP packet? Okay. He will check the destination. Okay, now destination is interesting. Destination is any. This means that he do not need to check the destination. So the destination IP address can be any IP address. This means I do not need to check. Okay. Then you also need to check the destination port. Okay. Destination port, or okay, if it's port 80 or port 443, okay, it's a match. So it matches. So you need to match the source IP, the protocol, and the destination port. Okay. Destination IP, no need to check because it's any. If all these matches, I will permit the packet. So the packet will be permitted to go. Okay. Okay, now notice was one more field that's missing. Source port number. Okay, what happened to the source port number? Okay, according to the syntax, okay, so it's permit, protocol, source IP. Source port number should be here. After the source IP, you should put the source port number here. Okay, the source port number should be here. But here is missing. Okay, meaning source port and also destination port. So if you have a source port, you should put equal and then the port number. But if I do not have a source port or I do not have a destination port, it means that no need to check. Okay, this means that this source port and destination port are actually optional field. You don't have to put it in. If you don't put it in, you're telling the router no need to check. So here no source port, that means source port I don't need to check. Okay. So I don't have to check source port, so all I need to do is destination port. Okay. So some of you may ask me, why no need to check source port? Okay, because if you know TCP IP, right, if this is a client, he want to contact a server out there. Okay. This client will use any source port number that's a random port number. Normally a port number that's more than 1023. So as a router, I could not identify what source port he will use. You can use any port number that's more than 1023. So I'm telling the router no need to check the source port. What is more important is the destination port. What this client is trying to connect. What service is it trying to connect? If it's trying to connect to port 80, port 443 to any server in the internet, then I will permit. Okay. Okay, next is this 104. Okay, I created another access list 104 and it's for established. Okay, the keyword here is established. Okay, what does this mean? Okay, here, okay, let's look at it. I'm going to permit again a TCP packet, okay, coming from this source IP, coming from any IP address. So anyone from the internet can come back, and if it's trying to come back to this is a destination. So let's say the packet is returning. So the destination IP address is going back to the 192.168 network. So as long as it's established connection, then I will allow the packet to pass through. Okay, what does this mean by established connection? Okay, established connection means anyone, okay, if a connection is initiated from someone inside, so someone go to a website and the reply packet come back, then this is an established connection. Okay. So you allow this kind of connection to connect back. So now I created a separate access list to control this kind of connection. Okay, to allow the return traffic to come back. So to allow established replies, HTTP, HTTPS reply, to come back to your network, so that the return packet can reach your go back to your source. Okay, now how should I apply the ACL? So I shall apply this ACL, these two ACL R1, both on serial 000 interface. For 103 is for the outgoing packet to the internet. Okay, so for the 104, for the return packet, it will be going in to my serial 000 interface.